Okay. All right. So we're gonna we're gonna do number 8 on page 121. So we have the integral. We're looking for the integral of 3/4 x to the 5th plus 5/3 x squared minus x over 2 dx. Now to solve this, to find this antiderivative, we're going to apply most of the rules that we have so far. All right? So the first thing I want to do is notice that this integrand has 3 separate terms, and one of the things that we can do with these integrals is to separate them into 3 separate integrals and apply the rules that we have to each separate integral. And so in a sense we're like distributing this dx and breaking this up into 3 separate integrals. 3/4 x to the 5th dx plus the integral 5/3 x squared dx minus the integral of x over 2 dx. Now we can work on each integral separately. Okay, so another rule comes into play here, and that is to simplify things, we can take this constant 3/4 and pull it out of the integral so that we can find the antiderivative of x to the 5th all by itself. We can do the same here with this 5/3, pull it out, and work on the antiderivative of x squared. And this is the constant 1/2. We'll take the 1/2 out and find the antiderivative using the power rule for integrals of x dx. All right, so here we go. We have this 3/4, which is a constant. We'll multiply that times the antiderivative when we're all done. Find the antiderivative of x to the 5th. The power rule says what we should do is add 1 to the power, the opposite of finding derivatives. Add 1 to the power and divide by the new power. 5 plus 1 is 6. And so here we'll get x to the 6th over 6 plus a constant plus 5/3 times the antiderivative of x squared, which is x to the 3rd over 3. You should know by now. Plus a constant. And finally minus 1/2 times the antiderivative of x dx, which is, this is x to the 1st power. So we'll do is add 1 to the power, making it x squared, and divide by the new power, which is 2, plus a constant. Now that's the answer. That's the antiderivative that we get, and we want to clean it up a little bit so it looks nice and pretty. And so here we can, let's see, this 3 will cancel with 6 and leave 2. And here we have x to the 6th over 4 times 2 is 8, plus a constant, plus, nothing we can cancel here, 5 times x to the 3rd is 5x to the 3rd, 3 times 3 is 9, plus a constant, and finally minus x squared over 4, plus a constant. And the last thing we can do is, since all of these c's are completely arbitrary and represent all numbers, we collect them all together into one big C at the end, and the answer we get is x to the 6th over 8 plus 5x to the 3rd over 9 minus x squared over 4. And that's the answer.